Today we're going to be talking about circles and segment lengths within our circles. So two chords length theorem. When two chords intersect inside a circle, the product of the segments of one chord equals the product of the segments of the other chord. So let's look at what we have here. We have AE times EB is equal to CE times ED. So you just look at the products of the different pieces or segments of each one of the chords. I can multiply the two segments of the same chord together. That's going to equal the product of the two segments of the other chord. Okay, solving for x. So this is our two chords. So I know that 10 times x is going to equal 8 times 5. 10 times x is equal to 40. If I divide both sides by 10, we get 4, not 40. So we get 4 there. Now, when we have a tangent and a secant and two secants, so two secant length theorem. Let's look at that one. And I'm going to highlight the most common mistake. Notice what the first thing is. It's the whole segment, EB times EA is equal to ED. Again, the whole segment times EC. Please keep that in mind. There's a lot of formulas in this chapter. And you have to remember the most common mistake that I find students are making is that they don't realize it's the whole segment EB. They just do EA times AB and EC times CD. It's the whole segment. Now the tangent and the secant. So if I were to move B infinitely close so that you get a tangent, so I have a tangent, that's why it's EA squared is equal to ED. Again, the whole segment times the little piece that's outside the circle. Okay, the whole segment. So let's do a couple examples involving these. Solving for x. So this is our secant and a tangent. So we have 10 squared is going to equal the piece outside, x, times, again, the whole segment, and the whole segment is x plus 12. Now it's a matter of simplifying. 100 equals x squared plus 12x. It's a quadratic. We need to get one side to be 0. Now you always first go with factoring. So the first thing that I do is I'm going to start testing some values that are going to, two numbers that are going to multiply to be 100, but we're going to add to be positive 12. 4 and 25. So the larger one has to be positive, so negative 4, that's not going to work. 20 times 5, the larger one has to be positive. Again, that one doesn't work. 50 times 2, larger one has to be positive. I don't think we have any that work. So what do you go to next? That evil quadratic formula rears its head. If you can't solve by factoring, you do your quadratic formula. So now you guys need to know this. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Where a, b, and c are the coefficients in front of the x squared, the x, and the constant term. So, solving our quadratic, we have x equals opposite of b, negative 12, plus or minus the square root of b squared, 144 minus 4, a, c is negative, all over 2a. On the bottom, we have a 2. On the top, I have 144 plus 400. And we have negative 12 plus or minus the square root of 544. 544 is equal to 16 times 34. I didn't know that off the top of my head. I did it in my calculator earlier. Okay, and something big like 544, I would let you guys use a calculator on that. So simplifying that, we have, I can pull out a 4. Now, things cancel. Remember that this means negative 12 over 2 plus or minus 4 root 34 over 2. Okay, so I have, what do I have there? I have x equals negative 6 plus or minus 2 root 34. So the 2 and the 4 cancel to be a 2. Those cancel to be a negative 6. Now you only have to pick one of them. Now let's think logically about this. Remember, this means two things. Negative 6 plus 2 root 34 and negative 6 minus 2 root 34. Well, this is a minus something, so this is even more negative. So that's a whole lot of negative. We're talking about x as segment length. That can't be negative. Let's make sure this first one isn't negative. Now, I'm not typing this in my calculator, but let me talk about how we could just know that intuitively. Root 34 is a little less than 6. It's probably about 5.8. 5.8 times 2, well, that's about almost 12. Negative 6 plus 12, well, that's still going to be positive. So that's how I know that's going to be our answer. Woo, stepping back, that's a lot of work on that page. Remember your quadratic formula. If you haven't taken note of that yet, hint, hint, you'll need it for the lesson questions. You know how I like to put those on quizzes. All right. Our last example, solving for x. So let's look at what we have here. You have two secants, whole segment. So we have 9 plus 15, the whole segment, times the piece outside, not the piece inside, the piece outside, times 9, equals the whole segment again. That's x plus 12. Times the little piece in that's outside the circle, which is 12. The left side simplifies to b. If I could write it correctly, I was thinking about that 9. Make note, I made a mistake. That should be a 15. This should be 360 equals 12x plus 144. Subtract 144 from both sides. That's 216 equals 12x. X is going to be equal to 18. Luckily, I didn't have to use that big scary quadratic formula again. Okay. Make note, I did make a mistake. I corrected it. I have the 15 out in front. Okay, there are your lesson questions. Please make sure they are submitted on time. I'm going to give you a strong hint. If you have to use the quadratic formula, which you will, and you have to type, say, the square root of 487, just put square root and then put 487 or whatever number on your Google form. Please make sure those are submitted on time.